All right, welcome to Krazifizix Medicine Science Clinic. This is one of our paper review sessions. In this session, we're dealing with Mathematics Paper 1. We're working with Mpumalanga 2016. This is part A, the first video of this session. Remember, you can reach us on www.krazifizix.org.za. Send us an email at info@krazifizix.org.za. Get on YouTube, type Krazifizix, you get a whole lot of videos that we've uploaded. As a school, you can send us an email, you can send us an SMS, or you can send us a WhatsApp message on 081-744-2103. We will be able to assist as we drive our maths and science. If you're in grade 10, this video is also applicable, to your knowledge. All right, so let's get on with this paper quickly without wasting much time. All right, so again, we're looking at paper 1, drilling the paper from the top to the bottom. All right, so let's have our paper review quickly and work with the paper. Okay, here I have question number 1. I would advise that you pause the video, answer the question, and then work through as we deal with corrections. My first question is this: x squared equals to 3x minus 2. So pause the video now, work through quickly, and play again. Now, what do we do here? Solution. X squared, we transfer this. We move all of this to the left side. It becomes minus, and if a minus moves, it becomes positive. You have 0. Now we must solve this quadratically. Let's find our factors. Let's check if we can find the factors, because this is a quadratic equation. All right, my product, doing this for grade 10. If you're in grade 10, this would benefit you now. My product is the last, and this, which is, remember, this is written as, okay, let me start by saying this is written as ax squared plus bx plus c, general solution here. All right, my product is always a times c, while my sum is b. Okay, so in this case, what is my product? Now write the equation again for clarity. So we have x squared minus 3x plus 2 equals to 0. What is my product? My product is positive 2, which is 2 times 1. All right, and what is my sum? My sum is negative 3. Now I need to look for the factors of 2. Two numbers that when I multiply would give me 2 would be 2 and 1. Right, but I need to add this number so that I get negative 3. To get negative 3, I need a negative 2 and a negative 1. So let's confirm. Negative 2 plus negative 1 would give me negative 3. Negative 2 times negative 1 would give me positive 2. Now, these are my perfect factors. So what do? X squared. All right, so I change my negative 3x into these values. All right, I could just actually say negative 2x, all right, minus x plus 2 equals to 0. This is still negative 3x. Now what I do is I look for what's common. All right, we'll try to pair them. What is common here? X is common. What do I have? X minus 2. And what do I have as a common factor here? I've got negative 1, and I also have x minus 2 equals to 0. Okay, you would notice that I have x minus 2 common to both sides. X minus 2 and x minus 1 equals to 0. Therefore, x equals to 2 or 1. All right, that's if you're in grade 10. That's the basic foundation of what we do. But now, if you are advanced on that, you can actually do this now. Minus 3x plus 2 equals to 0. Already you have your factors negative 2 and negative 1. So all you need to do, but you must understand the basics first. You have x there and x there. This x comes here and this x comes here. All right, and what are my factors? Negative 2 and negative 1, because negative 2, negative 1 would give me negative 3. Negative 2 times negative 1 would give me positive 2. So x equals to 2 or 1. All right, so that's how to deal with that with proper understanding. All right, let's go to the next one quickly. 2x squared plus 5x. Guys, we would extend our informations here, What is my product here? We must check first. My product is negative what? 16. And my sum is positive what? 5. What are the product of 16 factors? I have 16 and 1, I have 8 and 2, and I have 4 and 4. But if you look at all this pair, there is no way I am going to add or subtract that will give me a 5. Once that doesn't exist, then I run to what you call my quadratic equation, which is negative b plus quadratic solution, b squared minus 4ac over 2a, where my a equals to 2, my b equals to positive 5, and my c equals to negative 8. So grade 10s, this is how we work things out. And if you're in grade 12, you also need to just know that quickly. So what do? Minus, my b becomes what? 5 plus or minus square root 5 squared minus 4. What is my a? My a is 2 and my c is negative 8. Everything divided by 2 times 2. All right, so now what do? We run to our calculators where we get our answer here. All right, so I've got my calculator here, and what do I have? I have a negative 5, I've got a square root there, I've got a 5 squared, minus 4 in a bracket, 2, and I close the bracket. What do I have? Negative 8 over 2. This must come down here. All right, so I have 2 multiplied by 2. Okay, let's go check. It's negative 5. Okay, here we need a plus sign. So we're gonna do the first one with a plus and the next one with a minus. What's my answer here? I have a 1, 1. All right, 1, 1, 2 decimal places, 1, 1, 1. So x equals to positive 1, 1, 1, or what do? I go back again and just change the sign. You don't have to type the whole thing again. Just change the sign. The first one was plus, now it's going to be minus. And what do I have? I have a negative 3,61. Negative 3,61. Negative 3,61. And that's how you work that out. You have your 3 marks. All right, 1.1.3. If you feel that the video is moving too fast for you, please rewind and watch again. All right, 5x squared minus 3 less than 2x. This is inequalities, and a lot of learners find this very, very difficult. But let's simplify it for you. What you need to do here again is to bring that over. What am I going to have? 5x squared minus 2x minus 3 less than 0. The sign does not change. Is that okay? Now, what do? Again, this looks quadratic. What's my product? What's my product? My product here, I see that I could have a negative 15 as my product. Remember, it's 5 times that gives me negative 15. And my sum equals to negative what? 2. Now, do I have factors of 15? I have 3 times 5, all right? And I also have 15 and 1. So which one of them would possibly give me a negative 2? Okay, this one is automatically out. For me to have a negative 2, I need a 3 minus 5. Now let's check. 3 minus 5 would give me negative 2. Perfect. 3 times negative 5 would give me negative what? 15. Then I've got my factors. All right. So look at what I'm going to do here. 5x squared. I now introduce my signs here. All right. You can rearrange. You know, you could have, somebody would have this, minus 5x minus 3 less than 0. Okay, because you're just starting. But, you know, with experience, you can rearrange. There's a 5 and there's a 3. But let's see what to do here. What's common here? On the side, what's common and what's common here? Do you notice that x is common? What am I going to have? 5x plus 3. Remember, if I expand, I'm going to get that back. And what's common here? Minus 1. What do I have? 5x plus 3 less than 0 there. Always make sure you check. If you check this times this would give me negative 5, and that times that would give me negative 3. Then you know that you are correct. Now, what's common to both sides? You have 5x plus 3 common, all right, and then x minus 1 is left behind, less than what? 0. This is where we quickly talk about our critical values. In getting your critical values, this is what you do. 5x plus 3 equals to 0. 5x equals to negative 3. X equals to negative 3 over 5. That's the one critical value. Or x minus 1 equals to 0. X equals to what? 1. So I've got two critical values. These are not my solutions. They are just values for me. They are guidelines, critical values. That means x cannot be any of these ones. All right. So look at what I'll do. I'm going to draw a number line and write the lesser number on the left and the bigger number on the right. Now, what do I do here? Mathematically, okay, let me come back here and show you what we do mathematically, because we want you to really understand the concept here. If I were to pick a number here, for example 2, and put a 2 here, 2 minus 1 would give me 1, and this would be 10 plus 3, 13. Multiplying these two, remember I have a 10 plus 3, 13 here, and I have a 2 minus 1. It's positive. If I multiply both values, I'm going to get positive, which means any number on this side will give me a positive answer. Once you get one correct, automatically alternate them. It's plus minus plus. All right. Now, what we do is this. We are looking for something less than 0, which means it must be a negative. If it's a negative, that means I am looking at this frame here. From here, I must go this side to get a negative. From here, I must go this side to also get what? A negative. You know what you have done? You have simply answered your question. Your answers are within, they are enclosed between 1 and negative 3 over 5. But I want to show you something here. What I will simply say is x, look at the sign, greater than negative 3 over 5, or x, look at the sign, less than what? 1. But because they are enclosed, we can simply combine them and say that, and you have your answer there. All right. I hope that quickly helps your inequality manipulation. Remember your critical value, very, very critical and important. All right. Question 1.1.4. Remember, guys, just a quick one here. I am leaving this less. If this was less than or equal to, then I have to also put it less than or equal to. But it is not less than or equal to, it's just x less than 1. All right. 3x plus 1. Okay, let me use a black one. Plus 3. All right. Equals to 39. All right, what I need to do here, what I see to do here is to expand all of this by saying this means 3x times 3 to the power 1 plus 3x times 3 to the power negative 1. All right, lots of indices, plus 3x equals to 39. All right, what do you notice? I've got a common 3x there. So what do I have? I have 3 to the power 1 plus 3 to the power negative 1 plus 1. Because remember, we're saying 3 to the power x is common, so we have 1. If you remultiply and open your bracket, you're going to have all your equations back. So what do we do? If you use your calculator, 3 to the power x, all right, what will this give you? If you use your calculator, this will give you 3 plus 1, then you have 4, all right, and that would give you 4 1/3. That would give you 13 over 3. Okay, please use your calculator. 39. What do? I need to divide both sides by 13 over 3. So 3x, all right, equals to 39 divided by 13 over 3. Okay, I'm going to need space. 39. All right, let me just finish this calculation here. 39, so 3 to the power x equals to 39 times 3 over 13. All right, mathematically that can divide that, I'm left with 3. So 3x equals to 3 times 3, which is 3 squared. X equals to what? 2. And you're done. That's how you work things out there. All right, so please rewind the video and watch it over and over again as we move on to our next question quickly. All right, our next question would be question 1.2. All right, question 1.2. Okay, we need a new page there. Question 1.2. All right. Good. We copied this earlier so we can repaste our question and continue. Question 1.2. Given that 1 over 81 equals to 9y plus 3, and we have the other equation, so we got two equations. Show that y equals to 2x minus 3. Guys, we need to simplify this quickly. Now, what does this mean? This means 1 over 3 to the power 4. You can actually use your calculator if you don't know what to do. Look at this. If I were to say 1 over 81, let's just try to see something here. 1 over 81, all right, press that, equals to that. And then, all right, that's not actually giving me what I want. All right, in some calculators, there's a button there called fact, and that would actually help you get what you are looking for in simplifying all of that. All right, this would not give me what I want, but in your modern calculators, you'd have that. So let's just continue. All right, this gives me negative x equals to, I want basis of 3. This is 3 squared. Y plus 3. Already I'm moving close to what I want. So if I take this up, I'm going to have 3 to the power negative 4, because it's going up now, reciprocal, equals to 3 to the power 2y plus what? 6. Okay, what are we going to have here? Let's work through quickly. All right, what are we looking at getting on the side? Okay, just looking for space. All right, 3 negative 4 times that would give me a positive 4x equals to 3 2y plus 6. Now, since they have the same base, it means I can equate my exponent, 2y plus 6. But I'm looking for just y. So can I bring my 6 over? 4x minus 6 equals to what? 2y. I can divide through by 2. What am I going to have? 2x minus 3 equals to y. Y equals to 2x minus 3, which is what I really want to prove. All right, y equals to 2x minus 3. Now solve simultaneously. What this means is anywhere you see y in this equation, you put in the value of what? That's 2x minus 3. So what do I have? I've got x squared plus y squared minus 3x equals to negative 1. So x squared plus, what is my y now? My y is 2x minus 3 squared minus 3x equals to negative 1. All right, for grade 10 purpose, we are going to quickly show you how to expand. X squared plus 2x minus 3, 2x minus 3 minus 3x equals to negative 1. X squared. Now what we do here is we FOIL it. All right, you see the arrows would guide you to what you should multiply. Now 2x, the first black one, 2x times 2x would give me 4x squared, right? Okay, x squared plus 4x squared. Now 2x multiplied by negative 3 would give me negative 6x. Then I come to the side. Negative 3 times 2x give me another negative 6x. Negative 3 times negative 3 will give me positive 9. Minus 3x equals to negative 1. Or rather, you can simply bring this one on the side quickly and be smart with time. Okay, now what do we do here? We put all this together would give me what? 5x squared. This will give me negative 6x, which is 12, plus that would give me negative 15x. 9 plus 1 would give me 10, like terms. All right, equals 0. Now, quickly, you can see that they are all multiples of 5. So we can divide through by 5. X squared minus 3x plus 2 equals to 0. Oh, this actually brings me back to question 1. Do you see that? All right. And what do I have? X minus 2, x minus 1. If you want to remember how we got that, rewind the video to the beginning. So x equals to 2 or x equals to what? 1. But are we done? No. When x equals to 2, what is y? Now we substitute here. Y is 2x minus 3. So y is 2 multiplied by 2 minus 3. 4 minus 3, 1. All right. When x is equal to 1, what is my y? Y is 2 into 1 minus 3, which is 2 minus 3 would give me what? Negative 1. So what are my answers? We can put them together. When x is 2, y is 1. And when x is 1, y is negative 1. All right. You have 5 marks quickly there. 1.3. For which values of p will the equation, now this is talking about nature of roots. Once you see this, a quick summary about nature of roots, I'm going to help you now. It's talk about your discriminant, and this is equal to b squared minus 4ac. You remember this from our quadratic formula. Now when this now is equal to 0, what does it mean? It means your roots are real and they are equal. When your discriminant is greater than 0, your roots are real and they are unequal. Okay. I'm going to draw graphs quickly on this. When this now is less than 0, it means they are unreal. All right? They are not real. They're actually invalid. Or we can, invalid. We can say no solution in simple words. All right. So if this is my 1, 2, and 3, let's quickly draw graphs. Graph number 1, when discriminant is equal to 0. Look, it means it turns on the x-axis. All right? It turns on the x, no matter where. It turns on the x. All right? It just turns there. This is not turning. We're going to just manage that. All right? It turns there. So it turns there. You have equal roots. This one, you have 2 equal roots there. All right? So anywhere here, it just turns. Okay, I'm going to patch that through as well. It turns. It touches the graphs and turn. Actually, what we're saying, your x-axis actually becomes a tangent. There. What about number 2? When your discriminant is greater than 0, then you have 2 different points. Okay, it crosses. It crosses there. All right, it crosses. Okay, 2 different what? Points. You can see on every graph there are 2. 1, 2 there. 1, 2 for the red, for the green. There, they are real but not what? Equal. Number 3, when discriminant, just the signs, is less than 0, what do you have here? This doesn't touch, no solution. Whatever you do, it doesn't actually cut through the x-axis. So that's what we're talking about. Now, now this question says x squared plus x, 2p plus 4 plus 9p equals to 0 has equal roots. Automatically we're looking for where our discriminant is equal to 0, which is b squared minus 4ac must be equal to equal roots. All right. What is my a? My a is 1. What is my b? My b is the coefficient of x, 2p plus 4. And what is my c? My c is the 9 what? 9p. Now let's put all of that. What is b squared? 2p plus 4 squared minus 4 multiplied by 1, and my C is 9p equals to 0. All right. Unfortunately, I'm running out of page here. I'm going to need to check for another page quickly. All right, let me keep this. I want this my question kept. Okay. So I'm going to have to create another page quickly. All right. All right, we're here. Okay. So we said earlier on our b squared minus 4a must be equal to 0. 2p plus 4 squared minus 4, 1, and our c is 9p. That should be equal to 0. Let's expand all of this. All right. Now you should know what to do. 2p times 2p would give me 4p squared. 2p times 4 would give me 8p, but I need 2 of that. So 16p, all right, plus 4 times 4 would give me what? 16, minus 36p equals to 0. Okay, so let's deal with this. 4p squared. Now 16p and minus 36p would give me negative 20p. Negative 20p. Okay, plus 16 equals to 0. Do you notice again they are all multiples of 4? So p squared minus 5p plus 4 equals to 0. I hope that makes sense. Divide through. All right. Do we have product here? What are the two things that when I multiply will give me 4? I have 4 and 1. All right. So minus 4 and minus 1. Again, do you see why you need to learn how to factorize? It's almost in every maths question. All right. So you have p there, and then minus 4 minus 1. So it's either p equals to 4 or p equals to 1. All right, when p equals to 4 and p equals to 1, that will give me equal roots. All right, guys, that is question 1 done and dusted. All right, now let's run to question number 2 quickly. All right, question number 2 as we progress on. Now this with sequence and series. The first 4 terms of quadratic sequence are 1, negative 5, negative 13, and negative 23. All right. Okay, once you hear a quadratic sequence, guys, you must think about first difference and second difference. So let's calculate our first difference quickly. Our first difference, negative 5 minus 1 would give me negative 6. Negative 13 minus 5, you need to use your calculator. All right, negative 13 minus. Remember, there's a negative here. All right, that will give me minus 13 plus 5 will give me negative what? 8. And then negative 23 minus 13. All right, let me just show you what I'm saying. Negative 23 minus 13. It's negative 23 plus 13. That will give me what? Negative what? 10. Then we'll come here again and look for our second what? Difference. Negative 8 minus 6. Actually 6 minus 8 will give me what? Negative 2. Here it's going to be negative 10 minus 8. All right, negative 10 plus 8 will also give me what? Negative 2. You see now, I know I'm correct. My second difference must be the same. Now, what are my expressions? Let me try to write on the side. 2a equals to my first answer here. Here, it's 3a plus b. This you need to know. And on the side, it is a plus b plus c. All right, we need to know this quickly. So, let's equate now. If 2a equals to negative 2, what does it mean? A is equal to what? Negative 1. If 3a plus b equals to negative 6, remember my a is now what? Negative 1. So I have negative 3 plus b equals to negative what? 6. What would this be? It will be negative 6 plus 3, which is negative what? 3. All right. And then my A plus B plus C. Remember, let's go back. It's the first term, 1. What is my A? Negative 1, negative 3, plus C equals to 1. This would give me negative 4. Moving over to that side, positive, C becomes what? 5. Now, what's my general? Tn equals to an squared plus bn plus c. What is my A? My A is negative 1, so I have negative n squared, plus my B is negative 3, so negative 3n, and then my C is positive what? 5. And then you get how many marks there? 4. Which term has a value of negative 643? Which term? Now we're talking about Tn. Is negative 643. We are looking for n. So negative 643 equals to negative n squared minus 3n plus 5. This actually gives us a quadratic expression. Let's move everything from here to the other side. My n becomes positive. I have a positive 3n minus 5 minus 643 equals to 0. Standard form. All right. N squared plus 3n minus 648 equals to 0. I want to show you something beautiful mathematics here without using your calculator. Why is this important? NBT exams, and you'll find this in our math spectrum books. All right, how to deal with all of this without a single calculator. I need to find the factors of 648. All right, so let's quickly do this. Factors of 648. 2 here. This is 3, 2, 4. 2 would, because it's even. 1, 6, 2. I still have a 2, 8, and 1. All right. Now it's no longer even. 3, I have 27 here. 3, I have 9. 3, I have 3. And 3 divided by 3, I have 1. These are my factors. If you take your calculator now and multiply all of that, you would get 648. But I'm looking for 2 numbers. When I multiply them, I would get 648. When I subtract them, I would get 3. Now, a simple way. 2 times the next one here would give me 648. But if the difference would not give me 3, can I move to the next one? All right, look at this. 2 times 2, I'm stopping here now. 4, 162. 4 times 162, still not. Will give me 3. 2 times 2 times 2 will give me 8. 8 times 81 will give me 648. But the difference is actually too high. 2 times 2 times 2 times 3. This is 24. Now 24, you see I'm here, 24. All right, that's where I stopped. 24 times 27 would give me 648. We can confirm that quickly. 24, I just wanted to see. 24 times 27. There you go, 648. All right, but do you notice that 24, the difference, so here I've got 24. 24 and 27 would give me what? 3. Oh, perfect. So what do we do now? Look at how I'm going to deal with that. Let me write my equation again. So you need to rewind that, so that you see what we did. What's my equation? N squared minus n squared plus 3n minus 648 equals to 0. I said 24 and 27. All right. So n, we have 2 brackets, right? Equals to 0. I have a 24, I have a 27. Which one would go with a minus? Because I want a positive 3. So it's has to be 27 minus 24. So n equals to 24 or n equals to negative 27. But we're talking about number of terms. Our number of terms cannot be negative. So my correct answer is 24. So the 24th term would give me negative 643. All right, that's how you work things out. And you can confirm that on your calculator. 2.2. 2k plus 1. All right, 3k. 5k minus 5 are the first 3 terms of an arithmetic sequence. Okay, now we talk about arithmetic sequence. We talk about the common difference. Calculate the value of k. Okay, there are two ways to do this, but what we know is a common difference. D is t2 minus, okay, basically it's tn minus tn minus 1. So I could have d to be t2 minus t1. D is t3 minus t2. All right. And one thing I want us to see, 2d is actually t3 minus t1. All right. That's another method. Okay, let's try to make it simple for everyone. What is second term minus first term? My second term is 3k minus 2k plus 1. That should automatically be equal to what? Term 3 minus. Okay, guys, many learners do this and then you find wrong answers. I'll tell you what is wrong here quickly. I did this on purpose so that you would see. Look at 3k minus 2k minus 1. When you write it like this, you are going to get wrong answers. Every time you are putting a minus before a compound number, or complex number, not complex, compound, all right, more than one, you need to put a bracket. Complex number means something different. All right, 5k minus 5. Okay, just to maintain the principle, minus 3k. Let's expand now. 3k minus 2k minus 1 equals to 5k minus 5 minus 3k. All right, this would give me what? K here. K minus 1 equals to what? 2k minus 5. Now, if I bring this here, I have k minus 2k equals to minus 5 plus 1. Minus k here equals to 1 minus 5 would give me minus what? 4. Therefore, k equals to 4. All right, awesome. 2 marks. Write down the sigma notation for the first 20 terms. What you need to know, sigma notation is always the sum of Tn and then your range from here to here. Since it's talking about the first 20 terms, I will be dealing with from 1 to 20. But I must get Tn first. All right, how do I get Tn? By the way, I know now that my k equals to what? 4. If my k equals to 4, what do we need to do quickly? We need to substitute the value of k. All right, we substitute the value of k. My first term is 2k plus 1, so 2 times 4, 8 plus 1, my first value is 9. And my second one, 3k, 3 times 4, 12. My third value, 5k minus 5. 5 times 4, 20. 20 minus 5 will give me what? 15. Okay, can I get my common difference? What is my d? 12 minus 9, which is what? 3. Because I need to get Tn. What is Tn? A plus n minus 1d. It's on the formula page. Now, what is Tn? My A is 9 plus, what is my n? I do not know my n. However, I know my d. So, Tn equals to what? 9 plus, expand the bracket, 3n minus 3. Tn, therefore, 9 minus 3, 6 plus 3n. So already I have my Tn. So my summation would be 6 plus 3n. Guys, I am dealing with n. So n equals to 1 to 20, the first 20. That's my sigma notation. All right, 3 marks. Question 2.3. I hope you are enjoying the session so far. Given the geometric sequence 8x squared plus 4x cubed plus 2x. Now again, geometric. You know, I love this paper because this paper actually, in one full question, we've dealt with quadratic, we've dealt with arithmetic, and we're dealing with what? Geometric. All right. Geometric, I'm dealing with a common ratio. T2 over T1. Basically, Tn over Tn minus 1. For what values of x will the series converge? What is my rule of convergence? If you go to your formula page, you'd find this there. It means the rule of convergence. R must lie between -1 and 1. All right. Now, the question is, what is my R? What is my R? To get my R, I can say T2 over T1, like we said earlier on. 4x cubed over 8x squared. 4 divided there, 2. All right, you must understand mathematics and know maths. That there, what am I going to have? X over 2. That's my ratio. Okay, so I now come back here and say -1. Remember, this is our rule. But what's my ratio? X over 2. You need to just do this at the same time. Multiply everything by 2. -2, you have that, and you have 2 there. And that's the value of x. X must be between -2 and 2 for this series to converge. Calculate the value of x if the sum to infinity is 8 over 3. Okay, how do we do that? Sum to infinity. All right, I am going to need more space quickly. Let's get more space for ourselves. Let's get more space for ourselves. All right, let's see. Okay. Now, s to infinity equals to 8 over 3. What's my formula to s to infinity? S to infinity is a over 1 minus r. But now I know my infinity is 8 over 3. Now, what is my first term? All right, what's my first term? My first term is 8x squared over 1 minus, what is my ratio? We got x over 2. So we need to solve this now mathematically. Let's cross multiply. 1 minus x over 2, everything multiplied by 8 over 3 equals to 8x squared. Okay, mathematics now. We can basically expand here. All right, this multiplied by that and by that. So I'm going to have 8 over 3 minus 8x over 6. I hope you see 8 times that and this here. All right, equals to 8x squared. Now, to make our life easy, let's remove the fraction, the denominator, by multiplying through by 6. So if I multiply through by 6, 8 over 3 times 6 would give me 16 minus 8x equals to 48x squared. Okay, we can move everything over here to the side. What are we going to have? 48x squared minus, okay, let me arrange automatically, plus 8x minus 16 equals to what? 0. If you understand maths, I just moved these to the side, but I wrote it on the left hand side. All right, so that it looks standard. 48, remember, when this positive 16 goes, it becomes negative 16. When negative 8x goes there, it becomes positive 8. All right, look at this. This again is a multiple of 4. All right, actually a multiple of 8. Can divide through by 8. What am I going to have if I divide? Can I divide by 8? No. Okay, let's try to solve this. Dividing through by 8, what are we going to have? We would have 6x squared plus x minus 2 equals to what? 0. All right, now let's see quickly. I know you want to run to your quadratic, but I want you to practice. Product equals to 6 times -2, -12. And my sum is equal to positive 1. What are the factors of 12? 4 and 3 quickly. That's what you think of. But I want a negative. I want a positive 1. So 4 minus 3. Check this. 4 times minus 3 would give me -12. 4 minus 3 would give me 1. My factors are done. What do? Guys, once this is not 1, you can simply do this to make your life easy. All right, I'm going to now say plus 4x minus 3x minus 2 equals to what? 0. What's common on the side? All right, 2x. I see 2x common. What do I have? 3x plus 2. What's common here? There's a -1 that is common. 3x plus 2 equals to what? 0. What's common? 3x plus 2 is common, right? Factorize. And then you have 2x minus 1 equals to 0. What do I? Okay, quickly. 3x plus 2 equals to 0. X equals to -2 over 3. Or 2x minus 1 equals to 0. X equals to what? Half. All right. Calculate the values of x if s to infinity equals to 8 over 3. We got two values, x equals to what? Negative 2 over 3, or x equals to half. All right, 2.4. Let's see what 2.4 looks like. The first, third, and 13th terms of an arithmetic sequence are the first three terms of a geometric. Okay, this is combining things. If the first term of both sequences is 1, determine the first three terms. All right, let's quickly interpret. It's arithmetic sequence. Okay, I'm going to divide my board. Arithmetic sequence and geometric what? Sequence. My T1 equals to A equals to 1. My T1 equals to A equals to 1, because they said if the first term of both sequences is 1. All right, let's check something. The first is the first, okay? The third term of the arithmetic, what is my T3? A plus 2D. All right, and this is basically 1 plus 2D. These should be equal to, they said it's equal to the first three terms of the geometric, T2 here. And T2 here is AR, and my A is 1, remember? So we're actually saying here, 1, we're saying here, let me just create a space here. 1 plus 2D equals to what? R. Okay, the next one, the 13th term, A plus 12D. All right, that's coming from A plus N minus 1. My A is 1, 1 plus 12D, all right, and here it's equal to the first three, so T3. What do I have here? AR squared. Basically, we're saying R squared because our A is 1. So 1 plus 12D equals to R squared. The other one was 1 plus 2D equals to R. Let's see, 1 plus 2D, yes. So we have our two equations. What are we looking for? All right, calculate the first three terms of the geometric. So basically, I need to get what my R is. I need to get what my R is. All right. Either you look for R first or you look for D here. We don't have preference. You need to work with what works for you. To do this, we can actually look for D. Since I'm looking for R, let's learn it. We're looking for R, so let's substitute for D. From here, equation 2. From equation 2, 1 plus 2D equals to R. 2D equals to what? R minus 1. What is D? R minus 1. R minus 1 over what? Over 2. All right, is that fine? Now, anywhere we see D, can we put R minus 1 over 2? 1 plus 12, instead of D, R minus 1 over 2 equals to what? R squared. All right, 2 divided by 12 would give me, 12 divided by 2 would give me 6 there. So I have 1 plus 6R minus 6 equals to R squared. I hope you see what I did there. I expanded the bracket. 6 times R, 6R, 6 times 1 minus 6. Okay, since I'm going to have a quadratic equation again. All right, if we move everything over to that side, but write it on the side, R squared, my positive moving over that side becomes negative 6R. 1 minus 6 is negative 5, remember? If it goes over that side, it becomes positive 5, and that should be equal to 0. Do we have product? Our product is 5. All right, so do we have factors? 5 and 1. Negative 5 and negative 1 would give me negative 6. Multiply that will give me positive 5. All right, so what do I have? R minus 5 and R minus 1. So R equals to 5 or R equals to 1. But the question says, find the first three terms if R is greater than 1. So that means the only valid one, my only valid answer would be R greater than 1, which is R equals to what? 5. All right, so that's valid. Now, how do I find my first three terms? Remember, it's AR squared. My A is 1. 1 times 5 will give me 5. 1 times 5 times 5 will give me what? 25. All right, and we're done there. 6 marks. All right, determine the sum of 7 terms of the geometric sequence if the sequence is 1, 5, 25. 1, 5, 25. Now we're talking about the sum of a geometric sequence. What is the sum of a geometric sequence? Sn equals to a Rn minus 1 over R minus 1. Guys, you use this one when R is greater than 1. And you use this one when R is less than 1. But in this case, my R is greater than 1. So I am going to stick to this. Okay. What is my A? 1. What is my R? Remember T2 over T1. My R equals to what? 5. So what do I have? 5. What is my, this is S what? 7. Sum of 7 terms. Alright? 5 to the power 7 minus 1 over 5 minus 1. Here, don't use your head. Use a calculator. Okay, I normally tell my learners your head is too small to do this. Use a calculator. Okay, we have that. What do we have? 5 to the power 7, all right, minus 1 over 4. 19,531. 19,531. All right, question 2 is done. But quickly, before I go on to question number 3, I would like to quickly show you something that is very important that you must know here. Okay, let me look for a fresh page. We need to be able to deal with the proving of the sum. Proving of the sum of an arithmetic. All right, how do you prove that Sn equals to n over 2, 2a plus n minus 1 d? We need to be able to prove that. How do you prove that? A simple sequence that I need you to understand. Look at the number 10. 1 plus 2 plus 3 plus 4. That will give me 10. I am going to reverse this sequence and say 4 plus 3 plus 2 plus 1. That still gives me 10. All right, so look at what I'm going to do here. I'm going to say 2 multiplied by 10 because 10 plus 10 is 2, right? And that should be equal to what? Add down 5, 2 plus 3, 5, 3 plus 2, 5, 4 plus 1, 5. All right. So basically, you can actually say 2 multiplied by 10 equals to 5. How many terms here? There are 4 terms, right? 5 times what? 4. Can I divide both sides by 2? I wanted to check this. 10 equals to 5 times 4 divided by what? 2. Do you notice we are going to get 10 on this side as well? And that's the proof. That's how to prove it. All right, let's make sense now. So please rewind this video and quickly check my principle, because that's what I'm going to do. Now, what is Sn? It's the first term plus the second plus the third plus the last. Okay, so I'm going to do this now. Sn, what's my first term? It's A. What's my second term? A plus D. What's my third? A, we don't need to write all of them, all right, plus 2D. All right, I'll continue. What's my last term? Okay, the term before the last one, A plus, okay, I need space, and the space. Let me write the first 2 terms, all right, plus there, with 3 dots showing it's continuous, all right, plus my last term, A plus n minus 1 d. And if you want to show the term before the last one, it's going to be n minus 2, and the last one, A plus n minus 1 d. All right. Now I'm going to reverse this whole thing and say Sn. Remember what we did earlier on. I'm going to bring this one now to the side. A plus what? N minus 1 d plus A plus n minus 2 d plus 3 dots plus A plus d plus what? A. I want you to see. Can we add downwards? Equation 1 and equation 2. What am I going to get? A plus this one and this first term. So this is 2Sn equals to what? A plus A, 2A plus n minus 1 d. If you add this as well, you are going to expand this here. When you expand, you are going to get 2A plus n minus 1 d plus 3 dots. All the terms in between are also going to give us the same value, 2A plus n minus 1 d to the end. Now I have n number of terms. 2Sn, because they are n, in my example there were 4, so I said 4 times. But in this case, I'm dealing with what? N. So n multiplied by 2A plus n minus 1 d. What do I do now? I'm looking for Sn. So what can I divide both sides by 2? N over 2, 2A plus n minus 1 d. And then you have there. Sometimes it's 4, sometimes it's 5 max. All right, quickly. Geometric. How do I prove geometric? I want to prove this. All right. Okay, this is going to be a bit different. What we do here is this. First, what is Sn? Sn is A plus AR plus AR squared up to the last one, ARN minus 1. Now, multiply by R. You're going to have RSN. This becomes AR plus AR squared plus AR cubed. And then you continue, and then you get to AR. That's my last term, ARN. Now, I would say, if this is my equation 1 and this is equation 2, I'll say equation 2 minus equation 1. Okay, all right, let's bring this down a bit. So it's going to be RSN minus Sn equals to. Okay, remember now, just want to break it down. If I'm saying equation 2 minus 1, which means there's going to minus equation 1, there's going to be a minus in all the front of all these terms. So AR minus AR, that cancels out. AR squared minus AR squared, that cancels out. See, it's AR squared on top there, yeah. AR cubed will cancel the next one. So much that the term before this will cancel this out. And what am I left with? ARN minus A. So what do I do? What is common here? Sn. R minus 1. What is common here? A. Rn minus what? 1. All right. But what is Sn? A. Rn minus 1 over R minus 1. And you have your proof there again. All right. So that's how we work things out quickly. We're going to run to question number 3 now, still in our 1 hour time frame. Question number 3. Okay, this has to do with functions. All right. Sketched below are the graph of g of x, f of x, and h of x. What you notice if you look at the graph, my h of x is an exponential function. All right. My g of x is a straight line. All right. My f of x a parabola there, and you have your h of x there. A and B are the x and y co-intercepts of h respectively. Okay. We have an hyperbola, parabola, and a straight line. Okay. C, -6 into 20, and E at the point of intersection of F and G. All right, let's quickly look at this. First question says, calculate the coordinates of A and B. Let's check this quickly. Where is A and B? Here is A and B. And which graph is this? This is actually h of x. So h of x is equal to 6 over x minus 2 plus 1. How do I get my A? Do you notice A is on the x-axis, so it's the x-intercept. And at x-intercept, y equals to what? 0. So let's go put y equals to 0. By the way, h of x simply means y. So we're saying y equals to 6 over x minus 2 plus 1. But at point A, my y equals to what? 0. I'm looking for my x value. We solve mathematically now. This one comes over here. What does it become? -1 equals to 6 over x minus 2. what do? We cross multiply. Negative 1 times x will give me what? Positive x. And then I have a positive 2 there equals to 6. All right, no, it's a negative x. All right, and a positive 2. Negative x equals to 6 minus 2. Negative x equals to what? 4. What is my x value? 4. So what is my point A? My x value is 4 and my y value is what? 0. What about B? Again, on the same graph, what do you notice about B? B is actually my y-intercept, so my x value equals to what? 0. Since we're saying y equals to 6 over x minus 2 plus 1. But here I'm looking for my y value. My x value already is what? A 0. 0 minus 2 plus 1. Y equals to 6 divided by negative 2. That would give me what? Negative 3 plus 1. Y equals to negative 2. So what are my coordinates? X is 0 and y is what? Negative what? 2. What about the coordinate of E? The coordinate of E. What do you notice about E? All right. About E is a point of intersection between f of x and g of x. But there's so many ways. But number one, we don't know f of x, so there's going to be a problem there. All right. But what do you know about g of x? All right. At E, g of x now is equal to, what do I know here? At E, my y value is equal to what? 0. I'm going to explain this in two ways. Let me start using g of x first. Negative 2x plus 8. Remember, this also means y value. But what do you notice? At point E, our y equals to 0. So 0 equals to 2x plus negative 2x plus 8. All right? We can therefore say negative, 2x equals to what? 8. And x equals to what? 4. So what's my coordinate there? It's 4, it's 2, 0. Okay, I wanted to look at something here, alternative method. Let me clean all of this for clarity. This is negative 4. You've got a parabolic graph here. This is the midpoint or the turning point. This line is called the line of symmetry, which means it divides this graph into two equal halves. Now, if you look at these to this line, it's 4 units to the left. Automatically, I'm going to have 4 units to the right. So starting from 0 to the left is 4, negative 4. Starting from the middle to the right will be positive 4. So this value will be 4 and 0. That's another way. Okay. Show that the value of C equals to negative 16. Where do you have C? C is on my f of x. What do you know about f of x? X squared plus what? C. Do we have any coordinate, any point? Look at C. Point C there. It's actually resting on f of x. All right? Now, with that, I know my x equals to negative 6 and my y equals to what? 20. Remember, this means y equals to x squared plus what? 6. What is my y value? 20. What is my x value? Negative 6 squared plus c. 20 equals to 36 plus c. C, if we move this over, it becomes negative what? 16. It's negative 16. Let's try something else. Do you notice point A is also on my y f of x? Point A, even point E. What is the coordinate here? Negative 4. And here you have 4. Okay, let's try something. Now, since A is also on f of x, I can also say y equals to x squared plus what? C. What is my y value at A? 0. X value at A? Negative 4 squared plus what? C. 0 equals to what? 16 plus C. C equals to negative what? 16. Using point what? A. Because point E is also there, E, you remember E is 4 to 0. What do I have? Y equals to what? X squared plus C. Y equals to 4 squared plus C. Y equals to 16 plus C. By the way, my y value, because it's on the x-intercept, is 0. So what do I have? C equals to negative what? 16. So we have about 3 ways of proving that. Write down the values of g of x minus f of x greater than or equal to 0. Okay, many learners like doing this algebraically, but if you learn using a graph, it's actually very, very easy to work with a graph. And I'm going to work with a graph with you. All right, but first we can solve this by saying g of x must be greater than or equal to what? F of x. Remember, when we say g of x and f of x, we are looking for y values. The y values on g must be greater than the y values on what? F, greater than or equal to. First, where are they equal? They are equal at the point of intersection. Equal at the point of intersection. And where are these points? These points are actually E and C. Okay, because I'm looking at g of x and I'm looking at what? F of x. This is my point of intersection. Okay, they are equal at those points. And remember, we have our coordinates there already. All right, in order for us to be able to explain this section very well, I am going to try to, let me clean this part, or better still, okay, let's clean this part. Now, we want where f of x, where g of x is greater or equal to what? F of x. Now, look at your x value. Let me use a red ink here. Look at my x-axis. Is that fine? Let's check something here. On the side here, what do you notice? So I'm going to clean that again. Look at the value of g of x. Pick any value of x here. Let's check a value of x and trace it down. What is my g of x? It's a negative value. If I trace it, what's my f of x? It's a positive value. Which means at this particular point, f of x is greater than g of x. That's not what I want. I want the other way around. That means I cannot use any value from here. But I can use E, point E. Why? F of x is equal to g of x. That's one of the conditions I need, equal to. Okay, what about moving to the left side? Let's pick a value from here. Please don't get confused. Let me use a blue one now. If I pick any value beyond that line, what do you notice? Do you notice that my g of x now is what? Positive. And my f of x is negative, which means at a point before E on the left side, my g of x is greater than my f of x, which is what I want. All right. Even at point 0, let's check point 0. My f of x is negative. My g of x is positive. Okay, that still works for me. A point here, let's check. What is this? G of x, positive. Trace it down. F of x, negative. That works for me. All right. What about this point A? They are what? Equal. Again, that works for me. Greater than or equal to. Anywhere beyond this, remember this is negative 4. Anywhere beyond this, negative 4.1 or negative 4.2, whatever value. Do you notice that? Let me just for clarity. Okay. No, they are actually equal at negative 6. Sorry, negative 6. They are equal. All right, at negative 6. Any point beyond negative 6, what do you notice? Let me check negative 7. Negative 7. Do you notice that my f of x is now greater than my g of x? This, I don't need that anymore. So what are my values? My values that satisfy this condition lies between negative 6 and 4. Negative 6 and 4. Let's clean that again, just for clarity now. Between negative 6 and 4, my g of x will always be higher than my f of x. At this point, they are equal. At this point, they are also what? Equal. Okay. At this point, they are also equal. But between that, my g of x is greater than my f of x. So my value of x now, x should be less than, what's my value of e? 4 there. And between negative what? 6, greater than or equal to. That's your answer. It is quite always easier to solve graphically, because sometimes it gives you a complex equation and then we find challenges dealing with that. That's how you deal with such questions quickly. All right. Determine the equation of symmetry axis of h if the gradient is negative. Okay, let's go check our functions quickly again. Let's check our functions. I want the equation of symmetry. Now, please note, the equation of symmetry must actually pass through the intersection of your asymptotes. This is my asymptote. All right. Okay, I'm going to drag this line later on. All right. That is my equation. That's my line. That is my line. Do you notice that my line passes through the point of what? Intersection there. Okay, what is the function h? My function h is 6 over x. Let's go get the value. 6 over x minus 2 plus 1. I cannot answer this. First thing I need to do is to look for my asymptotes. And in getting your asymptote, guys, x minus 2 equals to 0. X equals to 2. So that's your equation there. If you check, look at my equation here. X, this is my x equals to what? 2. What about my y value? My y value is this. Y equals to what? 1. So here's my equation. Y equals to 1. Those are my asymptotes. So I know my point here already. My point here is what? 2 and 1. What do I need to know about the line of symmetry of such a function? All right. My gradient equals to a unit. It's a unit gradient, which is 1. But in this case, they said my gradient is what? Negative. So my gradient is negative 1. Now, what is the equation of this line? Analytical geometry. I need a gradient and I need a point. What's my point? 2 into what? 1. Y minus y1 equals to what? Mx minus what? x1. Y minus, what's my y value? 1. What's my gradient? Negative 1, right? X minus 2. Let's solve this together. Y equals to negative x, all right? Multiply, and then multiply plus 2. Take that over plus 1. Y equals to negative x plus 3. That's your equation of a straight line. And we're done there. Show that the length of BE equals to 2 root 5. Where's my B and my E? I always like writing my coordinates. What's my coordinate of B? On the y-axis, x is 0. I think we got a negative what? A negative 2. I need to go back so long, but I can quickly calculate that again here, because my x, I don't want to go back on this video. It's going to take me a while to find it. 0 minus 2. All right, so 6 over negative 2. All right, because remember on my y, my x is 0, right? That's why we have 0 minus 2 plus 1. This is negative 3 plus 1. And that gives me what? Negative 2. So this is the coordinate of B. And what is the coordinate of E? The coordinate of E, x is 4 and y is what? 0. Distance of BE. How do I find the distance of BE? Okay, there are quite a few ways. Let's quickly, you can use your distance formula. X squared, no, x2 minus x1 squared plus y2 minus y1 squared. All right, that's just one way in case a learner wants to find something the comfortable with. All right, this is my x2, 4 minus 0 squared, y2, 0 minus minus 2 squared. What will this give you? 4 times 4 would give us 16, and this will give you 2 times 2 will give you 4. So 2 plus 4, square root of 20. All right, and if you use your calculator, it's 4 times 5, which is 2 root what? 5. That's what the question wants us to do. But is there another way to deal with this? All right, is there another way to deal with this? If you look at OBE, OBE is a right angle triangle, BEO. Coordinate of this is 4 and 0. Coordinate of this is 0 and -2. And the coordinate, because it's the origin, automatically it means I have 4 units here. Because of this 4. Automatically I have 2 units. Now I'm looking for BE, Pythagoras theorem. BE squared equals to OE squared plus what? OB squared. Now BE squared equals to, what is my OE? 4 squared plus 2 squared. BE equals to the square root of this is 16 plus 4, 20, and that gives us 2 root what? 5. Okay. Write down the range of S. If S of X equals to, now my S of X is H of X plus 2. This graph is actually shifting. It's shifting. What's my H of X? 6 over X minus 2 plus 1. And then we have that. Now this is my S of X. What am I going to have? My S of X will be what? 6 over X minus 2 plus 3. The range is my Y values. All right. Range is my Y values. Remember, since this graph is shifting, my asymptote becomes what? 3. So it means my Y values, Y belongs to a set of all real numbers, but Y cannot be equal to 3. That's the range. Range means output. When you hear the word domain, it's talking about the X value, which means input. But range is your output. 3.7. If T, this is the last question for this session, if T is a tangent to F and parallel to G, okay, I'm going to try to just, let's see if I can get a straight line tangent. It's parallel to G, all right, parallel to G. Okay, there. That's my tangent there, parallel to G. Okay, determine the equation of the tangent T in the form of Y equals to mx plus c. Remember, it is a straight line. A tangent, Y equals to what? Mx plus c. But what do I know about parallel lines? Parallel lines have equal gradient. Equation here is Y equals to negative 2x plus 8. If you go back to the question, Y equals to 2x plus negative 2x, yeah, plus 8, which means the gradient of this line as well now equals to negative what? 2. They have the same gradient. For me to get the equation of a line, I need my gradient, negative 2 already, m equals to negative 2. Now I need a point x1 and y1. Where do I get that from? We must understand that the first derivative, all right, the first derivative is equal to the gradient of a tangent. So what's my equation? What's my f of x? Negative 2x plus what? 8. Okay? No, negative 2x squared, because I'm talking about my function, not my straight line now, all right? I'm talking about my function. It is x squared minus 16. Let's go just confirm, because I'm talking about, yes, x squared minus 16. So if I derive that, remember, this straight line is a tangent to f of x. So if I find the gradient here of f of x, it is going to be the gradient, the point of intersection here. So what is the gradient here? Is what? 2x. Is that okay? But I know that this must be equal to gradient. So 2x equals to negative 2. What is x therefore? Negative 1. Already I have my x value. How do I get my y value? I take my x value into the original equation, x squared minus 16. So negative 1 squared minus 16. What would that give us? 1 minus 16 would give us what? Negative what? 15. So My y value is negative 15. Let me write this out quickly. My m is negative 2, my x negative 1, and my y negative 15. Equation of a straight line. All right? So these are common things you do in papers. Negative what? 15 equals to negative 2, x minus negative 1, and then we have y plus 15 equals to negative 2x. Okay, let's do this. Negative 2, x plus 1. What am I going to have? Y equals to negative 2x, all right? Negative 2 times 1 would give me negative 2. And my positive 15 going on that side becomes negative. So y equals to what? Negative 2x minus what? 17. That's the equation of a line parallel to G. They gave me parallel to G so that I can get my gradient as negative 2, which is that. And I have my 2 points. Remember what we said. The first derivative is equal to gradient of a tangent, if there's a tangent. All right, this is where we are going to stop our first part 1 video on this paper 1 review. Remember, rewind the video and watch it over and over again. This is a production again of Krazifizix. Enjoy the video and watch out for the next one. This is Bishop signing out. All right, take care and goodbye. Enjoy.